I've already talked about what real life word problem have we most recently talked about that uses an exponential function. Car loans, okay? Car loans are exponential equations. There's a lot of other ones. The way things, anything that changes by a percentage is an exponential function. In biology and in chemistry, there's a lot of exponential growth and exponential decay. So it's happening very much in our real world. A lot of scientists using exponential functions, and then all of the finance industry. So there's a lot of application here. So the whole day is word problems. Here is our equation for growth. The initial amount is signified by this letter A. That's nice because A is the first letter of the alphabet. Initial amount, A. There's always a 1 for a growth or an increase. You do a plus sign. And then you put in the rate as a decimal. And the equation is the amount of time that goes by. Okay? Now, some things actually decrease by a percentage rate. And in that case, the math term for that is decay. Who's heard the word decay in life? Decay. Just take off your headphones. Push your phone away. I would like decaying like apple rotting. Yes, the way an apple decays is an exponential equation. I've heard the word decay at the dentist. Your enamel can decay on your teeth. Yeah. Who else has heard the word decay? Oh, I don't know. Right. Oh my gosh. You know what got me last time? They were like, Donkey Kong. And I was like, what are you talking about? Donkey Kong. DK. You got me. I had never, I was like, was it Rigo? Was it Rigo Virgil? No, it wasn't. Anyway, they got me. Alright, so that's decay. If something is decreasing or reducing by a percentage, we do the exact same formula, but there's a minus sign in it. It's going down. So if the base is less than 1, that's something that is decreasing. Whereas if the base is greater than 1, that's something that's increasing. So you can tell a lot about a stock or an investment if the base of that formula is less than 1, then it's losing value. If it's more than 1, then it's gaining value. All right. I'm going to go ahead and get you guys started on this right now. We're going to lose this handout. It's hole punch, so you can put it right in your binder. I will be checking to see that you're doing it. We're not going to finish it today. I'm going to do some of them with you. So our homework is going down. We want to take a big idea of math. Isn't there anything marked for Friday? Whenever we do Friday. Everybody was here. Take your hood off. No, we probably do. Yeah, but you gotta do that. Last Friday we did Connie gotta be that was too. Do it tonight. No, it should be due already. Like right now. What is it? That's crazy. Do you need more? You didn't know your own name. That's why I got a poster and phone one. What do you want? Somebody needs one over here. Alright, stop talking, y'all. Jacob, do you want to write this up here so you have it memorized? If you want to write it one more place, you need a hand up. Write it over the top. The more you write it, the better, so you can memorize it. We're going to use that formula on every single one of these. So go ahead and write it at the top. If you have your calculator, get out your calculator. If you don't, this is a little different. You have my permission to open the Chromebook and use the Google calculator. Please don't yell out like that. I have something important to say. The important thing I have to say is that we're about to do a huge project. It's with a test grade. Not today, but listen, if you don't have a calculator, you're going to have to use this calculator. So please, if you don't have a calculator, open your Chromebook and learn this right now so you can get credit on your project. If you don't have a calculator for this project, it's going to be bad news. So, no, listen to my words. Use the one on Google on the device in front of you. Okay? Just type in calculator. Well, the thing is that practicing on your phone buttons isn't as good as practicing on these buttons. Also, your phone gives you notifications, and you often get off track with those notifications. Just saying. Are you ready? Oh my goodness.
Yeah, that's what I needed.
They're also written here.
That one. In the green and that one. No, in the purple. Oh, tired. Yeah. Miss, are those ones in the purple and the green? Or is that an L?
Well, y'all, did you do Ballard? Did you do Ballard?
Yeah.
They are ones. Those are ones up there. Here, I'll make it a 1. There, that looks like a 1. There, that looks like a 1. Number 1. Find a bank account balance that starts with $100, has an annual rate of 4%. How much money is left after 12 years? Simple plug-in. Carter, you try it. What do you think we're going to put in the initial amount spot? The $100, absolutely right. 1 plus. That's the formula, 1 plus. Now we have a percentage here that has to be converted to a decimal. So to convert a percentage to a decimal, we move 2 places over, and it will be 0.04. So my R value is 0.04. It says I'm going to keep my money in for 12 years. So 12 is an exponent. Now, can you put that into a calculator and get it right? My advice to you on the TI-30 calculator, first off, you can put it all in there at once. Go ahead and try it. But on this calculator, what I might do is inside the parentheses, that's this right here. This right here we call quick math. 1 plus 0.04. There's really no reason to keep it apart. So I would just mental math make that 1.04. Right? That's easy, adding 1 to something. And then I would hit the YX button. And then I would hit 12 equal. And then I would hit the multiplication sign 100 equal again. That's the button.
Wait,
That's not right. It starts at the 100. It says 100 up.
We can't distribute.
Do not distribute when there's an exponent outside of parentheses. Okay? 1.04 to the 12th power is 1.6 times 100. My value is approximately $160.10. I'm going to answer in a complete sentence. After 12 years, the balance is $160.10. Yes, please answer in a complete sentence. What? So how much did it grow? How much did the account grow by? $60. You didn't earn 160, you earned 60. Let's try again. What is the subject in number 2, Elijah? What's number 2 all about? The growth of cell phones is pretty substantial. So this is looking at 1985. That's probably when your parents were born. You know, give or take 5 to 10 years. All right. So back then, in this small town of Centerville, there was only about 285 cell phones.
Why is your phone so down?
I gotta fix that. Okay. Anyway, so cell phones, the technology can increase very quickly because it grows exponentially. So this is the case of that. These cell phones went up 75% per year. That's kind of unheard of in other industries. So we're starting with 285. We always do 1 plus. The rate is 75%, and it started in 1985. They want to know how many were there in 1994. How many years would have gone by? 9 years. Let's see if you can put that in a calculator and get a right answer out. In 9 years, how many more cell phones were there? Every year it increases by 70. It's
43,871. I got $4.87. What's that?
actually with people we run down. That's confusing, I know.
Oh, right.
Hey, that's a lot in just 9 years in one little town to go from 280 to over 43,000. Can you think of anything today right now that might be growing that quickly?
The cell phone. You got Netflix, car payment, mortgage.
There are certain stocks that take off, but it's kind of rare. I thought of an interesting idea. Well, do you guys know when TikTok started?
TikTok, oh yeah. 2006.
I would say tops 10 years ago. Like it did not exist before. When I started teaching, it just wasn't really here. Oh, 2016 on the internet. So anyway, so that grew even quicker than cell phones because there's millions. So that grew at a rate higher than 75%. That's viral. You know what else? I thought of this one last class. How many of you guys have ever had an air fryer in your kitchen? An air fryer. Now, 4 years ago, did you have an air fryer in your kitchen? No. So, in the last 4 or 5 years, every household got an air fryer. Not everybody, but a lot. So, the people who made the air fryer probably got very wealthy because of the rate at which air fryers went viral here in the United States. Everybody go. What? All right. Shh. You guys be quiet. Shh. Stop, Parker. Don't do that again. That's your warning. All right. Our next one is talking about biology. At some point, you will need to take a biology EOC. We'll be talking about things like this. Bacteria can multiply at an enormous, alarming rate when each bacteria splits into 2 cells, thus doubling. If we start with 1 bacteria and it doubles every hour, how many bacteria will we have at the end of 1 day? Does anybody right now feel like they could plug everything in to write the equation? You want to try? You guys, to be honest, you should be able to at this point. Can anybody tell me the initial amount? It says we're going to start with 1. So we're going to put 1 in the initial amount. Here's where the 2 comes into play, guys. Yeah, let's talk about that word doubling. When something doubles, it increases 100%. If you have $10 and you double it, how much do you have? 20. That's 10 and 10. So when something doubles, it goes up by 100%. So the decimal is 1.0. How many hours are in a day? Our time period here is hours. There's 24 hours in a day. So when I put this together, when something is doubling, the base is 2. So when something doubles, you have a base 2. If something triples, you have a base 3. Quadruples, you have a base 4. This is like the folding the paper to the moon thing, because when you fold the paper, its thickness doubles. Did I show you guys the video?
Yeah. I think we should watch it again.
2 to the 24th. Put it in your calculator. What do you get? The bacteria goes from 1 to 16 million in 1 day. This is how we get maybe exposed to someone's sore throat. We don't notice it. One little bacteria gets in our throat. You wake up the next morning, raging sore throat. That's because that one bacteria went to 6 million in 24 hours because they're able to double like that. That 6 million starts to really affect you. Now, what happens if you don't go to the doctor? Doubles again. And then you don't just feel it in your throat. You feel it in your nose. You feel it in your ears. What kind of medicine does the doctor give you for a bacterial infection? Antibiotics. The antibiotics. What happens if you don't get antibiotics? White blood cells. White blood cells will work too. Your body. Your immune system. Okay.
Wait, what is it? My parents were born in 8th grade. I swear it was at the beginning. That was, bro, it was 7th grade. What was the beginning? COVID? Oh, what? I get monkeypox. That new update? Who's the teacher?
Are we ready for the next one? Alright, this one, if anybody in here follows like Sweet 16 NCAA, then maybe you're good with brackets, tournament brackets. This is a tennis tournament bracket, like Wimbledon. Alright? Now, what's the initial amount? Read the problem. What goes in the A spot? Alright, some of y'all are getting it. You guys, I messed up right there. Listen, each round, half are eliminated. So if you lose once, you're out of the tournament. Elimination implies a decrease. So this is our first word problem where we have to really read the letters and use the subtraction sign. Carter, why does this one require a different formula? Why? What word is our clue to that? What's the percent for half, y'all? 50%. So in our equation, we're going to put 0.5. So this time, since it's going down, we use the minus sign. 0.5 in 5 rounds. How many are left? Carter, get off the thing and do this, okay? Oh, it's in England. I mean, tennis is huge in Australia, and I don't really follow it, but I thought it was in England, but I could be wrong. There's something in Australia. Yeah, their natural ground is like a tennis court, so people had them in their backyards and they could play for low money. The natural clay ground was like, so they didn't have to have anything put in. They just needed the net. They could play off the ground. Elijah, what are you saying, man?
They said Wimbledon. Wendell did it.
Yeah. I know. What's the answer? What's the answer? I must have been wrong about the fire drill. That's my bad. Yeah. So guys, starting with 128 and half every single time the loser's eliminated, it only takes 5 rounds to get to the semifinals. I'm pretty sure that's where we are in the NFL, aren't we? How many teams are left? 4. We got that's the semifinals. After that, the Super Bowl.
My mom's underrated. I ain't know it.
How many NFL teams are there?
32. Debo hurt, bro.
How many rounds did it take to get to the Super Bowl?
3 to get to it. I'm gonna say, bro. I would say 3. What do you mean by that? You don't watch NFL, bro. I watch NHL, NFL. I watch
Alright. Alright, you guys, be quiet. I'm gonna try to do 3 more. Okay. Three more. You guys be quiet. Number 5 is really important. Conversation over. Then we're gonna talk about like how long when you breathe in something it stays in your lungs, and then we're gonna talk about how long ibuprofen stays in your body. So we have 3 more, you guys. 3 more. Number 6, Elijah and Parker, stop talking. Okay, I don't want to hear your voice again. Okay, you're done, Elijah. Stop talking now. All right. You haven't heard? Nope, I'm on 5. The population of Winnemucca, Nevada is modeled here. The equation is given for you. This is like your assignment today. You have to pick out the important parts. T is the number of years since 1990. What was the population in 1990? The equation is written for you. Which number tells us the initial amount? That's correct. Sometimes they're going to give you the equation and then they're going to ask you, do you understand where the details go? Do you understand where the initial amount is? And do you understand where the rate is? And do you understand where the time is? All right. So the initial population was 6,191. What percent does it increase each year? Put it as a percent. No, it's 4%. I knew this was going to be Jesus' topic. It's 4%. First off, take the 1 out, because it's 1 plus. Convert your decimal to a percent. Boo boo, 4%. So I wanted to show you, sometimes they flip the problem. They give you the equation and you have to pick out the important details. You see the yellow? It's given. Okay. So you have to know that the number in front is the initial amount. The number next to the 1, that's the interest, but you have to convert it. Okay? If there was a number up here, that's the number of years. Let's do the lung problem. I didn't know this about air until I did this. No, I'm skipping 6 for now because I think we only have maybe 2 more, and then everyone's kind of bored of this. We'll go to something else. So when you're normally breathing, so not like yoga or anything, a normal breath, 12% of the air is replaced. So you take a big breath in, exhale, take another one in. Only 12% of fresh air goes in there. Write a decay model, that means a subtraction, for the amount of original air left in the lungs if the initial amount is 500 milliliters. How much is left after 240 breaths? That's a long time. Can you write the equation, you think?
And then 12%, so 0.12, and then the power is going to be 240.
Yeah. So what you're thinking about, let's say you were standing next to the gas pump at the gas station and you got that strong smell of gasoline. You drive away. How many breaths does it take till that gasoline is out of your lungs? Or maybe you're stuck. Yeah, it's weird to think when you exhale, your lung doesn't completely deplete. It doesn't go empty. It actually stays 88% in there. So if you're stuck in like a fire and your lungs get filled with smoke, when you go out and you breathe fresh air, do you feel right away? No. No, it takes a long time till your lungs get fully fresh air circulating through them because only 12% of clean air goes in that first breath. And then 12% again and 12% again. So when you're exposed to toxic substances, it takes a while. And if your lungs actually become injured or get diseased or they're not that healthy, then they're not working at a 12% clean rate. They're working at a lower rate. So when someone has to get an ambulance, sometimes like no matter what their injury, they just put the oxygen right there because they help their lungs work better. When you're in the hospital, sometimes it doesn't even have anything to do with your lungs, but they'll get a oxygen on you to get fresh air circulating. Did you guys get a weird exponent when you did this? No, you do 1 minus, which leaves 0.88. Okay, that means every breath there's 88% of that original air still in there. 240 breaths. I wonder how long that takes. Seems like a long time. Times 500. This is what it looks like. So I want to remind you guys about scientific notation. This is the -11. So what that means is we could think about it under 1. Or that's what mine said. I did 0.88 to the 241st, and then I multiplied 500. Did you get an E value?
Oh, mine does. No, mine.
So, you guys, what that means, that's scientific notation. That's your calculator's way of doing that. So, the amount of like toxic air would be this much. Still detectable 240 breaths later. Really stays in there. But how many breaths do we take every minute? Every minute? Every day? So it's more than 1. Breath? That's too many. 10 because this was an 11. I did 10 zeros and I did this.
It's 12 to 18 breaths per minute.
Okay.